Hello guys, welcome back to my channel. This is Pragna Ashita studying Shri Venkateswara College of Engineering, Bangalore. Today I'm going to discuss about TCP IP model in computer network. Understanding the TCP or IP model in data communication and networking. First of all, TCP is defined as Transmission Control Protocol, and IP is called as Internet Protocol model. It is a fundamental framework that governs how data is transmitted over the internet and other networks. It is a crucial concept in the field of data communication and networking, providing a standardized set of protocols and guidelines for the effective data exchange between devices. This presentation will explore the layers of TCP or ICP IP model, their functions, and how they work together to facilitate seamless communication across various network environments. Introduction to the TCP or IP model. First one is understanding the fundamentals. The TCP or IP model is a conceptual framework that describes how data is transmitted over network from the physical layer to the application layer. It serves as a standardized language for the communication, ensuring interoperability between different devices and technologies. Second one is historical significance. The TCP or IP model was developed in the 1970s by the US Department of Defense as a way to interconnect different types of computer networks. It has since become the de facto standard for the internet communication, allowing for the development of the World Wide Web and countless other network applications. Third one is key principles. The TCP or IP model is based on the principles of open architecture, interconnectivity, and end-to-end communication. These guiding principles have made the model both flexible and scalable, enabling the growth and evolution of the internet as we know it today. The four layers of the TCP or IP model. First one is physical layer. The physical layer deals with the physical and electrical specifications of the network, such as cable types, signal transmission, and device connectivity. It ensures the data can be reliably transmitted over the physical medium. Second one is link layer. The link layer, also known as the data link layer, is responsible for packaging data into frames and controlling access to the physical medium. It ensures reliable and error-free data transfer between directly connected devices. Third one is internet layer. The internet layer, often referred to the network layer, is responsible for logical addressing and routing of data packets. It ensures that data can be delivered to the correct destinations even across multiple networks. First one is the physical layer. Its hardware specification is that the physical layer defines the electrical, mechanical, and functional specifications for the physical connection of devices to a network. This includes the characteristics of the transmission medium such as cables, connectors, and signaling. Second one is signal transmission. At the physical layer, data is transmitted as electrical or optical signals over the physical medium. The layer is responsible for the encoding, modulation, and synchronization of these signals to ensure reliable data transfer. Third one is device connectivity. The physical layer specifies how devices are physically connected to the network, including the use of network interface cards, that is NICs, hubs, and switches. It ensures that the correct hardware is used to establish a connection and maintain signal integrity. The next one is the link layer. Framing. First one is framing. The link layer takes the data from the internet layer into frames and packages into frames, which includes headers and tailers to provide information about the data, such as the source and destination address. Second is access control. The link layer is responsible for controlling access to the physical medium, ensuring that only one device transmits data at a time to prevent collisions and ensure reliable communication. Third one is error detection and correction. The link layer implements error detection and correction mechanisms such as checksum calculations and retransmission of lost or corrupted frames to ensure the integrity of the transmitted data. Next is the internet layer. First one is logical addressing. The internet layer is responsible for logical addressing using protocols like IP, that is Internet Protocol, to assign unique addresses to devices on the network, enabling end-to-end communication. Second is routing. The internet layer determines the optimal path for data packets to travel from source to destination using routing protocols to make decisions about the best routes based on factors like network congestion and distance. Third one is internetworking. The internet layer facilitates communication between different types of networks using devices like routers and gateways to translate between protocols and ensure seamless data exchange. Next one is the transport layer. First one is end-to-end communication. The transport layer is responsible for ensuring reliable and end-to-end communication between applications using protocols like TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, to establish connections, manage data flow, and handle retransmissions. The second one is segmentation and reassembly. The transport layer breaks down data from the application layer into small segments known as packets or datagrams and resembles them at the receiving end to ensure the complete and accurate delivery of information. Third one is error correction and flow control. transport layer implements mechanisms for error correction and flow control such as sequence numbers, acknowledgements, and congestion control to maintain the integrity and efficiency of data transmission. Next one is the application layer. So first one is user-facing services. So the application layer is where user-facing network services and protocols reside, such as web browsers, email clients, file transfer protocols, and instant messaging applications. So these services provide the interface for users to interact with the network. Second is protocol specifications. So the application layer defines the specific protocols and formats used for various network applications, ensuring compatibility and interoperability between different software and systems. Examples like include HTTP for web browsing, SMTP for email, and FTP for file transfers. So next is data formatting. The application layer is responsible for formatting and structuring the data that is to be transmitted over the network, taking into account and the specific requirements and conventions of the application being used. So how the layer works together. First one is data flow. If data is transmitted over a network, it passes through the various layers of TCP or IP model, with each layer performing its specific functions and adding or removing relevant headers and information to ensure effective and reliable communication. Second is encapsulation. So data is encapsulated as it moves down the layers, with each layer adding its own headers and tailors to the data until it is finally transmitted as raw bits over the physical medium. So the reverse process occurs when data is received at the destination. And third one is abstraction. The layer structure of TCP or IP model provides a logical abstraction, allowing each layer to focus on its specific responsibilities without needing to know the details of the further layers. So this modular approach promotes flexibility, scalability, and ease of implementation. So let's jump into the conclusion and key takeaways. So first one is standardized communication. The TCP or IP model provides standardized framework for data communication, ensuring operability, and between different devices, networks, and technologies. This has been instrumental in the growth and ubiquity of the internet. Second is layered architecture. The layered architecture of the TCP or IP model allows for modularity, flexibility, and scalability, enabling the continuous evolution and adoption of network technologies to meet changing needs and requirements. Third one is end-to-end connectivity. So the TCP or IP model facilitates a seamless end-to-end communication between the applications and devices, regardless of the underlying network infrastructure or physical medium, making it a fundamental building block of modern networking and communication systems. So thank you guys. Thank you for watching. Please like, share, and subscribe to my channel.